Stars are born in the nebula. A nebula can be 1 to 100 light years across. Inside a nebula, gravity and heat increase, which causes hydrogen to fuse into helium, forming stars. After hydrogen fuses to make helium, it is a protostar. It continues to pull in matter together until eventually, with enough matter, it creates a star. That process creates a main sequence star. Eventually, gravity takes over a star, and then the star dies. Low-mass stars are born in a nebula. The composition of a main sequence star is greater than 98% hydrogen and helium. 1/3 of the original hydrogen is converted to helium. Two examples of a main sequence star are our Sun and Altair. The time that a star is a main sequence is 90% of its lifespan, and the mass is 0.8 to 10 solar masses. A red giant is more than 100 times their main sequence mass. The mass is 99% of original mass. The time is 10% of its lifespan, and specific ones are Aldebaran and Arcturus. In a planetary nebula, the outer layers of gas are ejected, while the star's core contracts into a white dwarf. Mass, all but 10 to 15% of the original mass is ejected. Time, tens of thousands of years, and specific ones are M27 and NGC. The core of a white dwarf is typically composed of carbon and oxygen. Other possibilities are neon, magnesium, and helium. The mass is 5 to 15% of the original mass, time 10 to the 15th or 10 to the 25th years, and specific ones are Mira B and Sirius. It's a hypothetical remnant of a cooled white dwarf. The universe's existence is too short to prove the existence of a black dwarf. The mass is less than 1.4 solar masses, and the time is 10 to the 33rd or 10 to the 45th years. Matter that is expelled from stars can eventually accumulate into new star-forming nebulas. High-mass stars are born in a nebula. Gas clouds collapse and matter accumulates on a protostar. The composition of a high-mass star is greater than 98% hydrogen and helium. 1/3 of the hydrogen is converted to helium. The mass is 10 to 150 solar masses. The time is 90% of the lifespan. Specific ones are Specia and Theta Orionis. Massive stars are capable of producing heavier elements, like iron, through fusion. The mass is a significant loss of mass. The time is 10% of the lifespan, and specific ones are Betelgeuse and Rigel. That are made up of hydrogen and helium are ejected out in the occurrence of a supernova. The mass is all but 10% of the original mass, time is seconds, and a specific one is Cassiopeia. A star collapses into a dense mass of neutrons. The mass is 1.4 to 3 solar masses. The time is 10 to the 33rd or 10 to the 45th years, and specific ones are Synechus X1 and the Mouse. A star's core collapses into an extremely dense matter. Even light cannot escape the gravitational pull. The mass is 3 solar masses, the time is 10 to the 70th or more years, and specific ones are Cyprus X1 and Sagittarius. Matter expelled from stars can eventually accumulate into new star-forming nebulas. First, gravity takes over a star. Then it creates a supernova and explodes and spreads elements everywhere. Elements such as oxygen, gold, iron, nitrogen, uranium, carbon, potassium, sulfur, sodium, hydrogen, and helium.